When we build a standard financial forecast, we usually rely on a single set of assumptions to produce one rigid trend line. But the real world is volatile, and a static model breaks the moment random chance enters the equation. To fix this, we use a Monte Carlo simulation. Instead of guessing one specific outcome, this method calculates thousands of randomized scenarios to show us the actual spectrum of probability. Today, we will take a basic static financial model in Excel and upgrade it into a fully automated one-click simulation engine. You do not need a degree in statistics or expensive specialized software to do this. We can build the entire tool using functions already native to Excel. We start with a standard spreadsheet already built, like a simple net earnings calculator. First, organize the workspace. Separate the sheet into 3 specific color-coded areas: blue for our input variables, yellow for the calculations engine, and green for our final target output metric. Next, set up a blank tracking table on the left side of your screen. Give it 2 columns, iteration number and simulated result. This is where we will log the thousands of scenarios we are about to generate. Now we replace our static input numbers with randomized formulas. This allows the spreadsheet to simulate variance on its own. This graphic illustrates the RAND function. RAND generates a random decimal between 0 and 1, giving every value an equal chance of appearing. This creates a flat, uniform distribution, which is perfect for modeling variables with a fixed minimum and maximum, like fixed costs. For variables that follow a bell curve probability, like variable costs, we use a different equation. We take the mean, then add the standard deviation multiplied by the inverse standard normal distribution of our random number. This forces Excel to generate values that cluster naturally around your average. With those formulas in place, tap the F9 key on your keyboard. This commands Excel to recalculate the sheet, generating a fresh set of random numbers each time. As you press F9, your output metric will bounce and shift. Your model is now dynamic, reacting to simulated volatility. This is the exact mechanism we are going to automate. Pressing F9 10,000 times manually is impossible, so we need to write a script to do it for us. Before writing any code, go to Save As and change your file format to an Excel macro-enabled workbook, or .XLSM. Warning tone: if you skip this step, Excel will permanently delete your automation script the moment you close the file. Next, navigate to the File menu, select Options, and click Customize ribbon. Find the checkbox labeled Developer on the right side of the menu and turn it on. Activating these native developer tools gives you access to Visual Basic for Applications, or VBA. This allows us to turn a standard spreadsheet into an automated computing environment. Faster, more urgent tone. Click your New Developer tab at the top of the screen, then click the Visual Basic icon. A new window will open. Insert a blank module and paste in the provided looping macro code. This script gives Excel a strict set of instructions. Recalculate the randomized variables, copy the final target output, paste that result into our historical tracking list, and repeat the process. But this macro will instantly crash if it does not know exactly which cells to copy and paste from. Look at this mapping diagram. Traditional Excel identifies cells with a letter and a number, like A2, but VBA requires strict numeric coordinates, row first, then column, so A2 becomes cells 2, 1. If your net earnings output is located in cell F32, you count down 32 rows and across 6 columns. In the script, you will type this exact location as cells 32, 6. By correctly mapping these specific coordinates in the code, the macro knows exactly where to pull the simulated data from and where to record the final log without crashing. Close the Visual Basic window. Back on the Developer tab, insert a Form Control button directly onto your spreadsheet and assign your new macro to it. Now click your Run Simulation button. The script takes over, rapidly recalculating the spreadsheet and logging thousands of distinct scenarios down the columns of your tracking table. Once the simulation finishes, you have a massive new dataset. You can evaluate this data using standard formulas like average to find your expected mean and STDev to measure the standard deviation, which gives you your risk variance. Your original static model offered one fragile guess that would break under real-world pressure. Now you have a mathematically backed average and a clear measurement of your downside risk. You have engineered a dynamic risk assessment tool. By leveraging the Monte Carlo method in Excel, you have replaced blind hope with statistical probability, giving you a comprehensive view of 10,000 possible futures.